in 17.2, we're going to step away from quadrilaterals and we're going to take a look at triangles. And specifically, we're going to determine whether a triangle is scalene, which means all sides have different lengths, isosceles, where two sides are equal to each other, or equilateral, where all three sides are congruent. So looking at number 2, we're going to begin by plotting these 3 points. Point A is at 8, 5. Point B is at 8, 1. And point C is at 4, 3. Begin by finding the lengths of all 3 sides, and then that will help us to determine what type of triangle it is. To do that, for side AB, all I need to do is count the number of units. And I notice that side AB is 1, 2, 3, 4 units long. So that's an easy one to count. However, we cannot count the same way, like we did just vertically up and down, for BC, nor can we do the same counting method for AC. We have to use either the distance formula or the Pythagorean theorem. Let's sharpen this up a little bit here. Bring this down. Okay. So if I want to find the distance from A to C, let's draw a little right triangle. And in this right triangle, this side is 2, and this side is 1, 2, 3, 4. So the distance from A to C is the square root of 2 squared plus 4 squared. And we can simplify the square root of 20 into 2 radical 5. To find the distance from B to C, I'm going to draw another right triangle. And we notice that it's the same right triangle that I drew above. This side is 2. Let's bring this back down. There we go. And this side is 4. And so the distance from B to C, again, is the square root of 2 squared plus 4 squared, which is the square root of 20, or 2 radical 5. So we have one side is 4, and the other two sides are 2 radical 5. Therefore, this is an isosceles triangle, since 2 sides are congruent. So we have a map here over on the right, and we're going to draw a triangle between the house of Jose, Ed, and Brad. And then we need to decide what type of triangle this is. Is it scalene, isosceles, or equilateral? So I'm going to label this vertex J right here, and this vertex will label it E for Ed and B for Brad. So I'm going to begin by finding the distance from J to B. So again, Pythagorean theorem. Make my right triangle. And we have side length here of 2. 1, 2, 3, 4, 5, and we have another side length of 6. So the distance from J to B is the square root of 2 squared plus 6 squared. And the square root of 40, whoops, let's try that again. The square root of 40 we can break down into radical 4 times radical 10, and therefore the distance is 2 radical 10. All right, so let's move around to the next side, B to E. And we have A squared plus B squared equals C squared. So let's see, we have another side that's 2, and this side across the bottom is 1, 2, 3, 4, 5. So the distance from B to E is the square root of 2 squared plus 5 squared. And the square root of 29 cannot be simplified. So right now at this point, we know that it cannot be equilateral because we would have two sides that would match and be congruent to each other. So we can definitely cross out equilateral. And finally, the last side is JE. So drawing our right triangle. And this side is 1, and this side is 1, 2, 3, 4. So we have 1 squared plus 4 squared. And that would be the square root of 1 plus 16, or the square root of 17. So we have 3 unique different side lengths. So we're going to say that this triangle is scaling. Now to see if the triangle is a right triangle, there's a couple of things that we can do. We can either use the Pythagorean theorem and plug in our 3 side lengths, or we can find the slopes of each of the sides to see if there are any opposite reciprocals. What we know is if we have slopes with opposite reciprocals, then we have perpendicular sides that form right angles. So I'm going to take a look. I think I'm going to use the slopes. And I'm going to begin with the slope of JB. So let's sort of clear this up here, and let's see if we can quickly. I was hoping that wouldn't happen. All right. And we'll go back to labeling J, E, and B. And we're going to find the slope of JB. So let's look at point J. Point J right here is -3, +3. And point B over here is 3, 1. So I'm going to find the slope between those two sides. And just a reminder, my slope formula is to subtract my y values and divide that by the difference of my x values. So the slope of JB, my y values, 3 minus 1, divided by negative 3 minus 3. And then next I'm going to find the slope. Let's do from J to E. So point E down here is at negative 2, negative 1. Negative 2, negative 1. So I'm going to find the slope between J and E. So I'm going to take the difference of my y values. 3 minus negative 1 is 3 plus 1. Negative 3 minus negative 2 is negative 3 plus 2. So far, I do not have opposite reciprocal slopes. So right now, it doesn't look like it's a right triangle, but I need to find the slope of segment EB to know for sure. So to find the slope between E and B, I'm going to use these 2 points. And I'm going to subtract my y values. This time I'm going to do 3 minus negative 2, which is 3 plus 2. 1 minus negative 1 is 1 plus 1. And we get a slope of 5 over 2. So once again, we notice that all 3 slopes do not have opposite reciprocals or are not opposite reciprocals of one another. So no, this is not a right triangle. And the reason is because so now we need to form another triangle, and this time we're going to connect Jose, Miles, and Brad. The next thing we need to determine is the distance from Jose's house to Miles' house is the same as the distance from Jose's house to Brad's house. Jose to Miles' house and Jose to Brad's house. So we're going to find the distance between JB and JM to see if they are the same length. So once again, using the Pythagorean theorem, I'm going to draw a right triangle to find the distance from J to M, and this side is 2, and and this side is 6. So the distance from J to M is the square root of 2 squared plus 6 squared. And then we need to find the distance from Jose's house to Brad's house, from J to B. And again, another right triangle, using the Pythagorean theorem. We have this side is 2, 1, 2, 3, 4, 5. This side again is 6. So we're going to see that we get the same square root of 2 squared plus 6 squared, which is same to radical 10. So yes, his claim is correct. And we can explain our answer by saying that we used the Pythagorean theorem and found the distance between the two. What kind of triangle is formed if you connect all their houses in the shape of a triangle? Well, because we know that 2 of the sides are the same, we know it's at least isosceles, but I need to find the third side. And the third side I can just count. 1, 2, 3, 4. This has a distance of 4. So the distance from M to B so since 2 of the sides are congruent, we would say that this is an isosceles triangle. Alrighty, let's go back to our grid, and we're going to plot a new location for James at -3, -5. All right, -3, -1, 2, 3, 4, 5. So here is James. At -3, -5. All right, so we're going to connect his house, Jose's house, and Malcolm's house, and see if it is a right triangle. And once again, I'm going to use the slope of J, let's see, let's call this slope of JOJA from Jose to James. And since that's a vertical line, we say that that is an undefined slope. I have a better idea. Let's use the Pythagorean theorem for this. All right. Let's use the Pythagorean theorem and see if this side 3 squared and this side 1, 2, 3, 4, 5, 6, 7, 8 and this side is, I'm not sure, but we can find that distance by using the Pythagorean theorem. We can actually look at this triangle and we notice that it is a right triangle because what we have here is we have a vertical line. And we'll draw this in a different color. We have a vertical line, and a horizontal line. And when we have a vertical line with a slope that's undefined and a slope of 0, we know that that forms a right triangle. So we're going to say, yes, this does form a right triangle. All right, so a little bit of a review here in number 6. We're going back to quadrilaterals, stepping away from triangles. And in this quadrilateral, we are given 4 side lengths. And what I notice about all of the side lengths is that they are all equal to each other. So here's what that means. It could be a square, or it could be a rhombus. Not a trapezoid, not a rectangle. All right, so if it is a square, what I have to have is opposite reciprocal slopes. And these are not opposite reciprocals, nor are these. However, we do have one pair of parallel sides, since both the slopes are the same, another pair of parallel sides. So we now know that it's not a square, which means it has to be a rhombus. And a rhombus is a parallelogram. And in a parallelogram, we have opposite sides that are, opposite sides have the same slope. So we can definitely see that this would be considered a rhombus. Okay, we're looking for all the figures where the diagonals are congruent. That is true in a rectangle. The diagonals are also congruent in a square. Now, the diagonals are congruent in a special type of trapezoid if it were isosceles. So I'm going to go ahead and just put in here isosceles and know that, yes, the diagonals would be congruent if it is an isosceles trapezoid. All right, the diagonals bisect each other, which means both diagonals cut each other into exactly 2 congruent parts, right down the middle. That is true in a parallelogram. That is true in a rectangle. That is true in a rhombus. And it is true in a square. In a kite, only one diagonal does the bisecting. Both pairs of opposite angles are congruent in a parallelogram, in a rectangle, in a rhombus, and in a square. Okay, so number 14, we need to plot these 4 points to determine what type of quadrilateral is PQRS. Here is point P. Here is point Q. Point R. And point S. It appears to be a rectangle. And so to determine whether or not it is a rectangle, first I need to find the distance of all 4 sides, and then I need to find the slopes of all 4 sides. So let's begin with the distance from Q to P. So 4 squared plus 1 squared. And then I'm going to find the distance. Let's go to the opposite side. From R to S. Which is also 1 squared plus 4 squared. have one pair of opposite sides that are congruent. And then from P to S, it looks like it is 2 squared plus 8 squared I'm going to do this really quick for you on the calculator so that you can see. So 2 squared is 4, 8 squared is 64, so that's the square root of 68. And then the distance from Q to R. And again, that is 2 squared plus 8 squared. And so what we know is it is at least a parallelogram since we have opposite sides are congruent. Now we're going to see if it is a right triangle, if it is a rectangle. So I need to determine if the slopes are opposite reciprocals. So we're going to begin with the slope of QP. All right, so here's Q and here's P. So 4 minus negative 6 is 4 plus 6. And 5 minus 3 is my difference in my y values, which gives me 10 over 2, or 5. We're going to go around the corner to the next side length adjacent to QP, where we're going to find the slope of segment PS. So that would be the slope between these 2 points. So let's do 4 minus 0 over 5 minus 2 which is 4 over 3. And as we can see, these are not opposite reciprocal slopes. So this is not a rectangle. It would have to be classified as a parallelogram. But let's just check to make sure that we didn't do anything incorrect and find the slopes of the other 2 sides. So going around the corner again from S to R. We have, let's do 0 minus negative 10 is 0 plus 10. And 2 minus 0. And finally, the slope of the last side, RQ. So we're looking at the slope between these 2 points. So we can do negative 6 minus negative 10, or negative 6 plus 10, and 3 minus 0. And once again, we get 4/3. So yes, this does confirm that we do not have opposite reciprocal slopes. These are not opposite reciprocals. So this is not a rectangle. There are no right angles formed, so this is a parallelogram.